So this example, the factors in the denominator, they're repeated. So x and x is repeated twice. X minus 1 is repeated 3 times. Okay. So technically, if you have x squared on the numerator, the degree has to be lower. So the general expression will be like ax plus b, right? But if you want to integrate that, it's still like confusing kind of. Right? I mean, we can do it, but it's not that obvious. So instead of doing it this way, this is how we do it. We express it as ax plus bx squared. It's not easier to integrate that expression there. But if you add this, we get this, right? Yes. So the pattern is this. See, there is x squared, so you get the first power first, the second power, and put another constant, just a regular constant. We're going to use the same pattern for x minus 1 too. So x minus 1c, x minus 1 squared d, okay, and x minus 1 cube e. If you have to add this, we get degree 2 on top too. Okay. But we write it this way because this is the easiest form which we can integrate in the end. Right, so a needs to be actually multiplied by not only by x, but also by x minus 1 cubed. B needs to be multiplied by x minus 1 cubed. C needs to be multiplied by x minus 1 squared and x squared. D needs to be multiplied by x squared and x minus 1. And E just needs to be multiplied by x squared. Okay, so we should expand that. It's very useful if you know your binomial expansion formula here. It's because you get x cubed minus 3x squared plus 3x and minus 1. Okay. So actually I'm going to multiply this x in while I'm at it and change that power just by 1 more, right? X, 2, 3, 4. For B, it's just same thing of what I just wrote earlier. Okay. So C, it's gonna be x to the power of 4, right? And then minus 2x squared plus x squared when you fully expand. And for D, it's going to be x cubed minus x squared plus ex squared. Okay, all under the same thing. Now, what's important for us is to collect the powers together. So the highest power here is to the power of 4, right? So there's 1 here, 1 here, and that's it. So it's a plus c. And then x cubed. 1 here. So I'm just going to cross out the one I used. Right. 1 here. Yeah. So, and actually I made a mistake. There's 1 here too. So actually I should maybe color it differently. Okay. 1 there. 1 there. 1 there. 1 there. So there's 4 arrows here, right? It's going to be 4 terms. Minus 3a plus b minus 2c plus d. Okay, then x squared, there's 1 here, 1 here, 1 there, 1 there, and this 1, 2, 3, 4, 5 terms. 3a, right, minus 3b, then plus c, minus d, and plus e, right? Okay, so how many x terms do we have? 1 here, 1 here, and that's it. Okay. So it's going to be just minus A and plus 3B. And then constant term, there's only one, which is minus B. Wow. All right, so let's compare. Okay, so minus B has to equal to 1. So B is equal to negative 1. Then minus A plus 3B must equal to negative 1. And we just found out that B was negative 1. So it's equal to 2. So A is equal to negative 2. Okay. Now, A plus C, the degree 4 coefficient, actually is going to equal to 0 because there's no degree 4 up there. I just found out A to be negative 2, so C must be negative 2. Also, C must be positive 2. Okay. Okay, so I found A, B, and C. Okay, so we're in a good position to find D and E, right? So this minus 3A plus B minus 2C plus D must equal to 1. A was found to be negative 2, so it's 6. B was found to be negative 1, so minus 1. Negative 4. So that gives you 1. So D actually is equal to 0. That's good. Lastly, 3A minus 3B plus C minus D plus E. There's no x squared term, so it's going to equal to 0. D is gone. A was equal to negative 2, so negative 6. B was negative 1, so positive 3. C was equal to plus 2. So that's negative 1, so E is actually equal to 1. Alright, so we found everything. So now I'm going to erase this and replace the A, B, C, D, E with what we just found. Okay, so we found A to be what? Negative 2. So it's going to be integral of negative 2 1 over x. B was equal to negative 1. So negative 1, right? 1 over x squared dx. C was equal to 2, right? So 2 integral of 1 over x minus 1. And D was equal to 0. And then E was equal to 1. So 1 over x minus 1 cubed dx. Okay, so now we're ready to integrate. Minus 2 ln of absolute value of x. That's going to be positive 1 over x. That's going to be 2 ln of absolute value of x minus 1. And this right here is going to be, okay, and the last term is this. If you use the power rule backwards, right, as x minus 1 to the power of negative 3. So here we have it. We can combine these two, I guess, right? So it's going to be like ln of x minus 1 squared divided by x squared. So it's going to be actually x minus 1 over x squared. Then plus 1 over x. That one you can write like this.